Welcome to Narada Academy. In this video, we are going to discuss about one-dimensional heat equation, wave equation, Laplace equation, and how to find the solution of these equations by using the method of separation of variables. And I am going to do few problems on all these three types. Okay. First, let us start with one-dimensional heat equation. The heat equation is given by K into dou square U by dou x square is equal to dou U by dou T. Okay. Here U is a function of x and T, and x denote infinite rod. That is, the x may be taken as length of the infinite rod. So it varies from minus infinity to infinity, and T is always positive. Okay. So for finding the solution of this heat equation, we use the method of separation of variables. So for that, I am going to assume U as a function of x into t. Okay, product of x and t. So from this, dou U by dou x equal to dx by dx into t. Because t is treated as a constant when you differentiate with respect to x. Here, this side is, we put partial derivative, and this side we are putting total derivative, because u is a function of two variables x and t, but this x and t individually, they are functions of single variable only. So when you differentiate this function, on the left hand side you will be getting partial derivative, on the right hand side you will be getting the total derivative. Okay, so dou u by dou x equal to dx by dx into t. T is constant with respect to x, so this t is as it is. So second time differentiation, dou square u by dou x square is equal to d square x by dx square into t. And similarly, if you differentiate this with respect to t, you get dou u by dou t equal to x is treated as a constant into dt by dt. Okay, so after finding these values, let us substitute all these values in the heat equation. Okay, so k into dou square u by dou x square is equal to dou u by dou t. This is the equation. So substituting these values, what will you get? K t into d square x by dx square is equal to x into dt by dt. Right. Now we are going to separate the variables. That means you bring all x terms to one side and t terms to the other side. So bring x terms to this side. So 1 by x into d square x by dx square is equal to what? 1 by kt into dt by dt. Right. Now, so we have two separate terms, one containing fully terms of x, other containing terms of t. So let me equate this to constant minus n square. Okay, right. So 1 by x into d square x by dx square is equal to minus n square. This implies what? D square x by dx square plus n square x is equal to 0. Okay, this is a second order ordinary differential equation with constant coefficients. So how to find the solution? Right hand side is 0, no? So this will have only the complementary function. So for finding the complementary function, what will you do? You write d square by dx square as m square. Okay, so m square plus n square equal to 0. So m equal to plus or minus in. So the roots are complex conjugates. So how will you write the solution? X is equal to, that is the complementary function is given by a cos nx plus b sin nx. So all these things you know while doing the ordinary differential equation. So from there I have obtained this solution. Okay, next let us come to t. So here dt by dt plus, when this kt goes to this side, it will be n square kt, no? So plus n square kt equal to 0. So this is first order linear differential equation. So the solution is given by t into e power, here integral n square k dt is equal to constant c. Okay, so t into, this will be what? E power n square kt, no? So bring it to this side, it will be c e power minus n square kt. Okay, so we obtain the solutions for x and t, but what is u? U is nothing but product of x into t, no? So u is equal to a cos nx plus b sin nx into c e power minus n square kt, right? Okay, so u of x comma t is equal to, so here this constant c is there, no? Already a and b are constant, so no need to write this separate c as a constant. So we can write the general solution as u equal to e power minus n square kt into a cos nx plus b sin nx. Okay, so you remember this solution for solving problems under heat equation. We will be using this formula for problems. Okay, then solution of heat equation for infinite rod. See, in the previous method I have shown you how to find the solution of an heat equation by the method of separation of variables. Okay, many ways are there for finding the solution. Here one more solution is given, complete solution is given by this formula. I am not going to derive the solution here, just you remember this solution. In this video I am not going to make use of this solution, okay, but you may be asked to find what is the solution of this heat equation, the complete solution you may be asked to find. So in that case you remember this result, okay. So here what is the difference between the previous one and this one is, in the previous case I have taken only the equation, but here they have given the condition that u of x comma 0 is equal to f of x, that is initially, okay, initially the value of u is given by f of x. So this condition is given here, okay. Whatever I have found in the previous cases, the general condition, okay, without any initial conditions I have found out. This is with initial condition, okay. Next one, solution of heat equation for finite rod. This is for infinite rod and this is for finite rod. So for finite rod case, the solution is u of x comma t equal to summation a n sin n pi x by l into e power minus n square k square pi square t by l square, where a n is given by 2 by l into integral 0 to l f of x into sin n pi x by l into dx. Now this L denotes the length of the rod. In the previous case the length of the rod is taken to be infinite. Here it is finite rod. So here the initial condition u of x comma 0 is equal to f of x, and the boundary condition, that is boundary condition means on the corners of the rod the temperature is equal to 0. Okay, these are the boundary conditions. So here also you remember this solution, you may be asked what is the solution of this finite rod. Okay, in that case you can directly write, but I am not going to do problems of this type. Okay, next one dimensional wave equation. So the wave equation is given by dou square u by dou t square is equal to c square into dou square u by dou x square. Okay, so this is the general form of wave equation. So for solving this I am going to find the solution directly by you know how to solve a second order partial differential equation with constant coefficients. No, in that way first I am going to find the solution. I have taken here only the equation without any boundary conditions. So here this equation, let me take d equal to dou by dou x and d dash equal to dou by dou t. So this equation will be c square d square minus d dash square into u equal to 0. So this will be factorized into cd plus d dash into cd minus d dash into u equal to 0. You know how to write the complementary function for this. U of x comma t is equal to phi 1 of, okay, x minus ct plus phi 2 of x plus ct. Okay, right. Then next one is, so this is one type of solution. Then the next one is whenever no initial or boundary conditions are given, we can take it like this. The next case is the same equation, the same wave equation with the infinite string, and the initial conditions are given. That is initially the value of u of x comma 0 is equal to f of x, and the velocity ut of x comma 0 equal to g of x. Okay, so u of x comma 0 and ut of x comma 0 are given to be f of x and g of x. In this case, okay, the solution is given by 1 by 2 into f of x plus ct plus f of x minus ct. This is derived from this equation only by applying this initial conditions, plus 1 by 2c into integral x minus ct to x plus ct g of x dx. Okay, in the previous case while doing the heat equation I have told you only the separation of variables method, but here I am going to have 3 different solutions. All the 3 we will be using for doing the problems. Okay, in different cases we will use different solutions. Okay, so this is one solution without any initial conditions. This is a solution with initial condition. Next I am going to find the solution by using the method of separation of variables. Okay, let us take u equal to x of x into t of t. Okay, so after differentiation I will get dou square u by dou t square is equal to c square into dou square u by dou x square. This is the wave equation, no? So you substitute. So x into dou square d square t by dt square is equal to c square dou square u by dou x square is nothing but t into d square x by dx square. Okay, now separate the variables. Bring all x to one side and t to other side. So 1 by c square t into d square t by dt square is equal to 1 by x into d square x by dx square is equal to, let us take it as minus n square. Okay, now the equation with x is given by d square x by dx square plus n square x is equal to 0. So if you solve this is like the previous case only, no? So if you solve this, you will get the solution as x equal to c cos nx plus d sin nx. Okay, here also this equation is the same type. Here the solutions are given by plus or minus nc. Okay, INC. So t is given by a cos nct plus b sin nct. Therefore, what is u? X into t, no? So a cos nct plus b sin nct into c cos nx plus d sin nx. So for wave equation, I have obtained 3 different solutions. With all these 3 solutions, I am going to do the problems. Okay, right. Then let us see what will be the complete solution for finite case, finite string. See, dou square u by dou x square is equal to 1 by c square into dou square u by dou t square, where x is a finite string of length L. Okay, the initial conditions are given as before. U of x comma 0 is equal to f of x and ut of x comma 0 is equal to g of x throughout this length L. And the boundary conditions, what about the value of u on the corner points? 0. And what about ut at the corner point? That is also 0. So initial and boundary conditions are given. Just you remember this solution, you may get question regarding this solution. Okay, just you remember, this is summation sin n pi bn into sin n pi x by l into cos n pi ct by l plus L by pi c into summation bn dash by n into sin n pi x by l into sin n pi ct by l, where bn is given by 2 by l integral 0 till f of x sin n pi x by l dx, and bn dash is given by 2 by l into 0 to l g of x into sin n pi x by L into dx. For doing some complicated problems in physics and fluid dynamics, we will be using this solution. But for this video, I am not going to make use of this formula. Okay, just I have stated what is the formula. Next one is Laplace equation. We very well know what is the Laplace equation in Cartesian coordinates. Dou square u by dou x square plus dou square u by dou y square equal to 0. First, let me find the solution by the method of separation of variables. So here u is a function of x and y. I am taking u equal to x into y. So dou square u by dou x square is y into d square x by dx square, and dou square u by dou y square equal to x into d square y by dy square. Substitute it here and separate the variables. Okay, so here y into d square x by dx square equal to minus x into d square y by dy square, equate it to minus n square. So what I get, d square x by dx square plus n square x is equal to 0, and d square y by dy square minus n square y equal to 0. Okay, so here it is positive, so the root will be what? Plus or minus in. So x is equal to a cos nx plus b sin nx. Here it is negative, so the roots will be what? Plus or minus n. Okay, real and distinct roots. In that case, y equal to c e power ny plus d e power minus ny. Therefore, u is given by the product of these two, x into y. Okay, so this is the solution. Next one, we are going to find the solution for this Laplace equation in polar coordinates also, that we will see later. Now let me come to Dirichlet problem. See, Dirichlet problem is nothing but the problem of finding the distribution of temperature within a body in the steady state. Okay, when each point of its surface is kept at prescribed steady temperature, okay, is an interior Dirichlet problem. So there are two types of Dirichlet problem. One is interior, another one is exterior. In both the problems, we are finding the distribution of temperature. Okay, for interior Dirichlet problem, okay, we are having that. What is that we have? Within a body in the steady state, when each point of its surface is kept at prescribed steady temperature. Here, okay, the problem of finding the distribution of the potential outside the body. Here we are finding the temperature outside the body when the surface potential is kept at constant. Okay, right. So this is called interior Dirichlet problem, and this is called what? Exterior Dirichlet problem. Then we will see one example, interior Dirichlet problem. If f is a continuous function prescribed on the boundary S of some finite region V, determine a function psi such that del square psi equal to 0 within V and psi equal to f on S. This is exterior Dirichlet problem. Here also the same kind of statement. F is a continuous function prescribed in the boundary S of a finite simply connected region V. Okay, we have to determine a function psi which satisfies psi square del square psi equal to 0 outside V. This is the only difference. Okay, so for interior Dirichlet problem, del square psi equal to 0 within V, and for exterior Dirichlet problem, del square psi equal to 0 outside V. But on the boundary of S, we have taken one simply closed curve, no, on the boundary psi equal to F. Okay, on the boundary psi equal to F, if you want to find the distribution within C, it is called interior Dirichlet problem. If you want to find outside, it is called what? Exterior Dirichlet problem. Next one is we are going to find the solution of Laplace equation in terms of polar coordinates. Previously we find in terms of x and y, no. Now I am going to find the same thing in terms of r and theta. Okay, Laplace equation in polar coordinates is given by like this: urr plus 1 by r into ur plus 1 by r square into u theta theta equal to 0. Okay, so here let me take this. Here also I am going to find the solution by separation of variables. Let me take u equal to r into theta. Okay, then ur equal to theta into dr by dr, and u theta equal to r d theta by d theta. Okay, and u double r, that is second derivative, theta equal to theta into d square r by dr square, and u double theta is equal to r into d square theta by d theta square. Let me substitute all these values in the Laplace equation. Okay, and let me separate the variables. Okay, that is, bring all theta to one side and r terms to the other side. Okay, and equate them to minus n square. Okay, first let me take this theta term, 1 by theta into d square theta by d theta square equal to minus n square. This implies d square theta by d theta square plus n square theta equal to 0. So here theta is equal to plus or minus in. The roots are complex conjugates. So theta is given by a1 cos n theta plus a2 cos n, a2 sin n theta. Okay, right. Now this side, r square by r d square r by dr square plus r by r dr by dr equal to n square. Now throughout you multiply by capital R. So you get r square d square plus r d minus n square into r is equal to 0. This is second order ordinary differential equation with variable coefficients. Okay, already I have uploaded video for solving second order ordinary differential equation with constant coefficients and also for variable coefficients. So if you want to know how to find the solution, you go to that video and search there. So here a very simple method only. The solution is given by r equal to b1 r power n plus b2 by r power n. So u is given by product of these two, a1 cos n theta plus a2 sin n theta into b1 r power n plus b2 by r power n. So this is the solution of Laplace equation where in case of polar coordinates. Okay, right. Next one, let me explain you interior Dirichlet problem for circle. Okay, so del square u is equal to 0 within the circle. Interior I told you, no. So del square is u is equal to 0 inside the circle, subject to the boundary condition u of a comma theta equal to f of theta. The solution is given like this: u of r comma theta. This is the solution. I am not deriving this. Okay, you may get a question, what is the interior solution of interior Dirichlet problem for circle? In that case, you write the solution. The solution is a0 by 2 plus summation r by a power n, an cos n theta plus bn sin n theta, where an is given by 1 by pi integral 0 to 2 pi f of theta cos n theta d theta, and bn is equal to 1 by pi integral 0 to 2 pi f of theta sin n theta d theta. Here we take the limit 0 to 2 pi because we are taking on the boundary of the circle, no. So the limits from 0 to 2 pi. Okay, exterior Dirichlet problem, the same thing. There is no difference between interior and exterior. Here you put del square u is equal to 0 within the circle. Here you put outside the circle. So r less than a means interior of the circle, r greater than a means what? Outside the circle, subject to u of a comma theta equal to f of theta. This is what? A boundary condition. U of a comma theta means when r equal to a, it denotes the boundary of the circle, no. On the boundary of the circle, u of a comma theta equal to f of theta. The same condition we have taken here also. The solution is, there is only a slight change in the solution. You see here a0 by 2, r by a power plus n here it is r by a power minus n. That's all. Okay, the others are same. So this is the solution for exterior Dirichlet problem for circle. Okay, then next one is Neumann problem. Similar to Dirichlet problem, this Neumann problem is there. Here also we have two types, interior Neumann problem and exterior Neumann problem. For interior Neumann problem, we have del square psi equal to 0 within V and dou psi by dou n equal to f at every point on the surface. Yes, that is the difference between Dirichlet problem and Neumann problem is, for Dirichlet problem, on the boundary, the value of the function psi is equal to some f. Okay, for Dirichlet problem, what? Psi is equal to f on the boundary. But for Neumann problem, dou psi by dou n is equal to f. That is the only difference. For both the problems, del square psi equal to 0. Okay, either inside or outside. On the boundary, for Dirichlet problem, you say psi is equal to some function f. For Neumann problem, you say dou psi by dou n equal to f. If del square psi equal to 0 within V, it is called interior Neumann problem. If del square psi equal to 0 outside V, it is called exterior Neumann problem. That's all. That's the difference. Okay. So we see what's the solution for interior Neumann problem for circle and exterior Neumann problem for circle. The same thing, del square equal to 0 within the circle, subject to what is the condition, dou u by dou r equal to f of theta on r equal to a, and in integral 0 to 2 pi f of theta d theta equal to 0. This must be 0, integral 0 to 2 pi. Okay, this is the necessary condition for existence of solution. This question you may get. Okay, what is the necessary condition for existence of solution of interior Neumann problem? For that you have to write integral 0 to pi f of theta d theta equal to 0. Okay, right. The solution is given by like this: a naught by 2 minus a by 2 pi integral 0 to 2 pi log of a square plus r square minus 2ar into cos of theta minus tau f of tau d tau. Okay, for exterior Neumann problem, there is a slight change. This will be plus. Okay, so these are the solution for Neumann problem, interior and exterior. Okay, now let me come to consolidation, what we have seen here. So here I have consolidated only the things for which I am going to do the problem. Okay, only the solutions which I am going to make use for the problems only I have taken here. So if you consolidate this, I will get it like this. The heat equation is given by k into dou square u by dou x square equal to dou u by dou t. The solution is e power minus n square kt into a cos nx plus b sin nx. For heat equation, only remember this solution. That is enough for doing the problems. Okay. For wave equation, dou square u by dou t square equal to c square into dou square u by dou x square. If nothing is given, you can simply take u of x comma t equal to phi 1 of x plus ct plus phi 2 of x minus ct. Otherwise, a cos nct plus b sin nct into c sin nx plus d sin nx. This we obtain by solving second order partial differential equation with constant coefficient. This we obtain by separation of variables. Both the formulas we will use, okay, for different problems. Next one, suppose with initial conditions are given. This is without any initial condition. Suppose if initial conditions are given, only one solution, u of x comma t equal to 1 by 2 into f of x plus ct plus f of x minus ct plus 1 by 2c into integral x minus ct to x plus ct g of x dx. This f is nothing but u of x comma 0 and g is nothing but ut of x comma 0. Okay, so for wave equation, remember all the three solutions for doing problem. For Laplace equation, in Cartesian coordinates, the solution is a cos nx plus b sin nx into c e power ny plus d e power minus ny. In polar coordinates, the solution is a1 r power n plus a2 by r power n into b1 cos n theta plus b2 sin n theta. Okay, with this table, let me start doing the problems. See, first problem, the function u of x comma t satisfies the initial value problem dou square u by dou t square equal to dou square u by dou x square for x belong to r. X belong to r means what? Infinite case. X varies from minus infinity to infinity. T is greater than 0 and the initial conditions are given. U of x comma 0 equal to 0 and ut of x comma 0 equal to 4x into e power minus x square. We have to find what is u of phi comma phi. Okay, now the one-dimensional wave equation, the solution for one-dimensional wave equation is given by 1 by 2 into f of x plus ct plus f of x minus ct plus 1 by 2c into integral x minus ct to x plus ct g of x dx. Why I am taking this solution? Because the equation, wave equation is given and the initial conditions are given, no? So we have to take this solution only. Here, for this problem, c value equal to 1. Okay, and f of x is equal to, f of x is u of x comma 0, no? This is 0 here for this problem, and g of x is ut of x comma 0, g of x is 4x into e power minus x square. So I have written all the given values. Let me substitute in the solution. U of x comma t is equal to 1 by 2 into integral, this will be 0, no, because the entire f is 0. 1 by 2 into integral x minus t to x plus t, c equal to 1, so it will be simply x minus t to x plus t, 4x into e power minus x square into dx. Let me integrate this. This 4x I can write it as what? This 2 and 2 get cancelled. Simply I will be having 2x. This 2x I am writing it as differential of x square. So this is like e power minus x into dx. So the difference, integration is what? Minus e power minus x square within the limits x minus t to x plus t. So if substitute the limits, minus e power minus x plus t the whole square plus e power minus x minus t the whole square. So this is the solution for the given equation. But the question is, we have to find what is u of 5 comma 5. So substitute x equal to 5 and t equal to 5 in this solution. So this is e power 0 minus this is e power 5 plus 5 is what? 10. 10 square is what? 100. So minus e power minus 100. E power 0 is 1 minus e power minus 100. That's all. So simply what is the thing you have to remember? If the wave equation is given, what is the solution? That just to memorize the table. For doing problems, the table I have given, no, that is enough. Okay. Right. Next problem. yxx equal to 1 by 9 into ytt minus infinity to infinity t greater than 0 and y of x comma 0 equal to x square and yt of x comma 0 equal to x. So the same like previous problem, here c value is equal to 3. This 9 is there, no, you should not take it as 9. This is c square only. So c equal to 3 and f of x is x square and g of x is x. So let us substitute directly in the formula. Y of x comma t is given by 1 by 2 into f of x plus ct plus f of x minus ct plus 1 by 2c into integral x minus ct to x plus ct g of x into dx. So f of x plus, let me substitute the value for c. So x plus 3t plus f of x minus 3t plus 1 by 6 into integral x minus 3t to x plus 3t x into dx. Okay, but what is f of x? F of x equal to x square. So this is f of x plus 3t means what? X plus 3t the whole square plus x minus 3t the whole square plus x. Just to integrate, so x square by 2 within the limit x minus 3t to x plus 3t. So now you simplify this expression. This will be what? X plus 3t the whole square plus x minus 3t the whole square. No, so this is 2x square, 2 into x square plus 9t square plus here it is simply xt. So therefore what is the solution? X square plus 9t square plus xt. Okay, next problem. Let u of x comma t be the solution of dou square u by dou t square minus dou square u by dou x square equal to 0. Again the same wave equation with the c equal to 1 and the boundary conditions are given. U of x comma 0 equal to f of x and ut of x comma 0 equal to 0. That is f of x is equal to f of x only, but g of x is equal to 0. Certain values are given, we have to find u of 1 comma 3. I will come to this one later. First let us find the solution with the initial conditions. Okay, now c equal to 1 for this problem and g equal to 0. So the solution is u of x comma t equal to 1 by 2 into f of x plus t plus f of x minus t. Okay, so this is the solution. Afterwards we cannot simplify. Now what is given? Now what is given? See, u of 2 comma 2 equal to 8 is given, no? Let me find u of 2 comma 2 equal to 1 by 2 into, if you substitute x equal to 2 and t equal to 2, this will be f of 4 plus f of 0 equal to 8. That means f of 4 plus, but f of 0 they have given as 0, no? So f of 4 plus 0 equal to 16, therefore f of 4 equal to 16. Okay, next what is given? U of 1 comma 3 we have to find out. U of 2 comma 2 is given. We have to find out what is u of 1 comma 3. U of 1 comma 3 equal to, you substitute x equal to 1 and t equal to 3 in this equation. 1 by 2 into f of 1 plus 3 is 4. F of 4 plus f of 1 minus 3 is minus 2. F of 4 plus f of minus 2. But I know what is f of 4, 16 plus f of minus 2 already given in the question itself. So 16 plus 4 is 20. 20 by 10, 2 is equal to what? 10. Okay, that's all. Next problem. Find the solution of the initial value problem. Utt equal to 4 into uxx, where t is greater than 0, minus infinity, less than x, less than infinity, and u of x comma 0 equal to x and ut of x comma 0 equal to 0. For this problem is also g is equal to 0 and f is equal to, f of x is equal to simply x and c equal to 2. The same type, so u of x comma t equal to 1 by 2 into f of x plus 2t plus f of x minus 2t. This will be 0. Okay, so f of x plus 2t is simply x plus 2t and f of x minus 2t is x minus 2t. Therefore the solution is what? X alone. Next one, dou square u by dou t square minus dou square u by dou x square equal to 0. U of x comma 0 equal to x square. That is f of x equal to x square and g of x is equal to 0. We have to find what is u of 0 comma 1. Okay, now g of x is 0, no? So the solution is u of x comma t equal to 1 by 2 into f of x plus t plus f of x minus t. Here it is x square, no? So it is x plus t the whole square plus x minus t the whole square. So 2x square plus 2t square. So simply u of x comma t equal to x square plus t square. So u of 0 comma 1 equal to 0 plus 1 equal to 1. Then next problem, a function u of x comma t satisfies the wave equation dou square u by dou t square equal to dou square u by dou x square. This is finite rod case, 0 less than x less than 1, t greater than 0. If u of half comma 0 equal to 1 by 4, u of 1 comma half equal to 1 and u of 0 comma 1 by 2 equal to 1 by 2. What is u of 1 by 2 comma 1? Though it is a finite rod, let us use the most general solution. I am not going to make use of the solution which I have stated there. Only the solution given in the table, that only I am going to use, and I am going to use the boundary conditions. Okay. The solution is u of x comma t equal to phi 1 of x plus ct plus phi 2 of x minus ct. See, here the initial conditions are not given. That is, u of x comma 0 and ut of x comma 0 are not given. Therefore, this solution only we have to take. Okay. Now here for this problem, c equal to 1. No? So, u of x comma t equal to phi 1 of x plus t plus phi 2 of x minus t. Okay. Next one. Given that u of half comma 0 equal to 1 by 4. That means phi 1 of half plus phi 2 of half equal to 1 by 4. Next, u of 1 comma half is 1. Implies phi 1 of 3 by 2 plus phi 2 of 1 by 2 equal to 1. Next, u of 0 comma half equal to half. So, phi 1 of half plus phi 2 of minus half is equal to half. So, we have three equations. From these three equations, we have to find the solution of u of 1 by 2 comma 1. First, let me find what is u of 1 by 2 comma 1. This is the question. We have to find the value for this. U of 1 by 2 comma 1 equal to phi 1 of 3 by 2 plus phi 2 of minus half. Isn't it? Now you see this 3 by 2 is here in this equation and minus 1 by 2 is here in this equation. Okay. So these two cannot get cancelled because this is phi 1, this is phi 2. But this phi 1 of half plus phi 2 of half are here. Okay. So for finding the solution for this, that is sum of these two, we can add these two equations, subtract this equation. Okay, so add these two equations. What will you get? Phi 1 of 3 by 2 plus phi 2 of half plus phi 1 of 1 by 2 plus phi 2 of minus half. Subtract it here. Phi 1 of half plus phi 2 of half. Okay, so the unwanted terms get cancelled. Okay, so this will be what? Minus 1 by 4. This will be 1 and this will be half. So it's equal to what? 1 plus 1 by 4 equal to 5 by 4. So this is the solution. Okay, right? So why I have taken this solution? Because the initial condition u of x comma 0 and ut of x comma 0 are not given. That's why I have taken this as the solution. Right? Next one, uxx equal to ut with 0 less than x less than pi and t greater than 0, and the initial condition u of 0 comma t equal to 0 and u of pi comma t, sorry, boundary conditions are given. U of 0 comma t equal to 0 and u of pi comma t equal to 0, and u of x comma 0 initial condition is 3 sin x. Okay, for this equation, what is the solution? U of x comma t equal to e power minus n square kt into a cos nx plus b sin nx. For this problem, k equal to 1. Okay, right. Now u of 0 comma t equal to 0. So let us substitute in this one. U of 0 comma t equal to 0 implies e power minus n square t into x equal to 0 means this term will be 0, no? So a cos nx is a cos 0. So a into e power minus n square t equal to 0. So exponential function is never vanishing function. So the only possibility is a equal to 0. So the solution will further reduce. U of x comma t equal to e power minus n square t into a is 0, no? So simply b sin nx. Okay, now u of pi comma t equal to 0. U of pi comma t equal to 0. Substitute in this equation. Don't go for the previous one. Let us continue with this. E power minus n square t into sin n pi into b equal to 0. Okay, right. With this one we cannot come to any conclusion. So keep it as it is. Next one is u of x comma 0 equal to 3 sin 2x. They have given, no? Okay, right. So u of x comma 0 is what? E power 0 into, right, e power 0 into b sin nx equal to 3 sin 2x. Okay, now you compare the left and right hand side. E power 0 is simply 1. The constant b is equal to 3 and n is equal to 2. Therefore, what is the solution? B equal to 3, simply you put 3 into e power n square is what? Minus 4 into sin 2x. So this is the solution. Okay, then next one. uxx plus uyy equal to 0, Laplace equation with x equal to x belong to 0 to pi and y belong to 0 to pi. U of x comma 0 equal to u of x comma pi equal to u of 0 comma y equal to 0. Okay, right. So the boundary conditions and the initial conditions are all given. Okay, right. Now let us find what is u of x comma y. U of x comma y is given by a cos nx plus b sin nx into c e power ny plus d e power ny minus ny. Now you substitute u of x comma 0 equal to 0. That implies a cos nx plus b sin nx into, this will be simply what? 0, 0, no? That is e power 0, simply 1. So c plus d equal to 0. See, this cannot be 0 because if this is 0, the solution will be trivial. So this cannot be 0. The only possibility is c plus d equal to 0. That implies c equal to minus d. So you substitute in this one. So u of xy equal to a cos nx plus b sin nx into c e power ny plus, instead of d I am substituting minus c e power minus ny. So take c outside, this will be what, e power ny minus e power minus ny. No, it is nothing but 2 sin h ny, hyperbolic function formula. So my solution is u of xy is equal to 2c sin h ny into a cos nx plus b sin nx. So with the first result I have simplified the solution to this side. Next let me take u of x comma pi equal to 0. Substitute in this one. We simply get 0, so no result is arrived from that one. Next one is u of 0 comma y equal to 0. Let me take this one, substitute in this equation, substitute x equal to 0, then a cos 0 is what, simply a, this will be 0 for x equal to 0, so I get 2c sin h and y into a equal to 0. This implies a equal to 0, because sin h and y, if you put 0 na, the entire solution will become 0, so the only possibility is what, a equal to 0. Right. So therefore u of xy is equal to 2c sin h and y into b sin nx. Therefore it's equal to 2bc sin nx into sin h and y. This constant simply I put it as k. So k sin nx into sin h and y. Okay. Then next one, dou square u by dou x square plus dou square u by dou y square equal to 0. X lies between 0 to a, y lies between 0 to b. U of x comma 0 equal to 0, u of x comma b equal to 0, u of 0 comma y equal to 0, and u of a comma y equal to f of y. Okay, the solution is given by a cos nx plus b sin nx into c e power ny plus d e power minus ny. As before the previous problem, we are going to substitute the conditions one by one and find out the values of a, b, c, d. Okay, u of x comma 0 equal to 0 implies a cos nx plus b sin nx into c plus d equal to 0. This cannot be 0, therefore c plus d equal to 0, which implies c equal to minus d. So proceed as before in the previous problem. You get it as 2c sin h and y into a cos nx plus b sin nx. Next one, u of x comma b equal to 0. That implies you substitute here 2c sin h and b into a cos nx plus b sin nx equal to 0. This cannot be 0, therefore sin h and b equal to 0 implies nb equal to k pi by b. That means nb must be multiples of pi. So k I take it as an integer constant. Okay, so nb equal to k pi or n equal to k pi by b. So the solution again takes the form 2c into sin h k pi by by into a cos k pi x by b plus b sin k pi x by b. Next one is u of 0 comma y equal to 0, isn't it? U of 0 comma y equal to 0. So you substitute it. What do you get? 2c sin k pi y by b into a equal to 0. That implies a equal to 0. So finally what is the solution? 2bc into sin h pi y by b sin k pi x by b. So this is the solution. This problem is almost similar to the previous problem. Okay, except the case that here we have over a rectangle, there we have from 0 to pi, here we have from 0 to a and 0 to b. Okay, right. Then next problem. Consider the following equation. Heat conduction problem for a finite rod, dou u by dou t equal to dou square u by dou x square minus x e power t minus 2t, t greater than 0 and x lies between 0 to pi with boundary condition u of 0 comma t equal to minus t square, u of pi comma t equal to minus pi e power minus t square, and initial condition u of x comma 0 equal to sin x minus sin 3x minus x lies between 0 to pi. This may look like a very tedious problem, and this equation we don't know. Okay, but here look at this one, v of x comma t equal to u plus x e power t plus t square. Okay, if you derive what is dou v by dou t and dou square v by dou t square, dou v by dou x, dou square v by dou x square, we will arrive at a simple level. Okay, now dou v by dou t equal to dou u by dou t plus x e power t plus 2t, and dou v by dou x is equal to dou u by dou x plus e power t. Okay, and dou square v by dou x square is equal to dou square u by dou x square. Right, now what is given? Dou u by dou t equal to this equation, dou square u by dou x square minus x e power t minus 2t. Only no, now you substitute the values. Dou u by dou t plus x e power t plus 2t is equal to dou square u by dou x square, but this is nothing but by dou v by dou t, and this is nothing but dou square u by dou x square. So my problem reduced to this. dou v by dou t equal to dou square v by dou x square. Now u of 0 comma t equal to minus t square given, no? So v of 0 comma t is equal to 0 and u of pi comma t equal to minus pi e power t minus t square. That implies v of pi comma t equal to 0. Okay, so the boundary conditions are obtained. Next, u of x comma 0 equal to sin x minus sin cube x minus x. This is what given. So v of x comma 0 equal to sin x minus sin cube x minus x plus x, no? So simply what? V of x comma 0 equal to sin x minus sin cube x. This is initial condition. Then next one is, what is the solution? E power minus n square kt into a cos nx plus b sin nx. For this problem k equal to 1. So it is v of x comma 0 equal to e power minus n square t into a cos nx plus b sin nx. Now v of 0 comma t equal to 0 implies a e power minus n square t equal to 0, which is simply a equal to 0. So what is v? V equal to a is 0, no? B sin nx into e power minus n square t. But v of pi comma t equal to 0 implies 0. So we don't get anything from that result. Next, v of x comma 0 equal to sin x minus sin cube x, no? So you substitute b sin nx is equal to sin x minus sin cube x, because this will become 1. When substitute t equal to 0, this will be 1. Simply b sin nx equal to sin x minus sin cube x. So here this side sin nx only, here we have cubic term, no? Just you split it. Sin x minus 1 by 4 into 3 sin x minus sin 3x. So what you get? 1 by 4 into sin x plus sin 3x. So substitute it here. So v of x comma t equal to e power minus here when n equal to 1, this will be what? E power minus t sin x. When n equal to 3, it is what? Here n takes two values. One is 1, another one is 3. Okay. B is equal to 1 by 4 only. But this n takes two values. So you have to write it as sum of two terms. E power minus t into sin x plus e power minus 9t into sin 3x. Okay. That's all. Thank you.